transfer function given है. This is transfer function of an overlap transfer function and I have to draw its Nyquist plot. Nyquist plot ड्रॉ करने के पीछे रीजन है कि मुझे उसकी स्टेबिलिटी फाइंड आउट करनी है. इसका मतलब जो मैं स्पेसिफिक रीजन लूंगा that reason will be right hand side of S plane. So सबसे पहले मैं निकालूंगा C1 के लिए. That was lying S plane के ऊपर. I will find out for this reason S j omega goes from 0 to infinity. यहाँ रखो S की जगह z omega. G j omega H j omega 1 divided by j omega plus 2. We will calculate its magnitude and phase for different values of omega going from 0 to infinity. Its magnitude and phase. इसका magnitude हुआ क्या? Let's do scale. Phase minus 90 minus tangent inverse omega by 2. Its magnitude and phase for different value of omega. Omega 0 1 by 0 for omega is equal to 0. This value will be 1 by 0 into something. 0 into something 0. 1 by 0 infinity. Its phase minus 90 minus tangent inverse 0. Tangent inverse 0 is 0. That will come out to be minus 90 minus 0. Minus 90 for infinity. Magnitude will be 1 by infinity under root infinity square plus something. That will come out to be infinity square. Infinity square under infinity 1 by infinity square. That comes out to be 0. So magnitude is 0. Angle minus 90 minus tan inverse infinity. Tan inverse infinity is at minus 90 and 90. Minus 90 minus 90. This will come out to be minus 180. This all calculations were regarding S is equal to j omega. Now we will do calculation for C2. C2 was this circle. C2 is R limit R tends to infinity R e raised to the power j theta, where theta goes from pi by 2 to minus pi by 2. Now we are going to calculate for C2. That will comes out to be 1 divided by R e की power j theta divided by R e की power j theta plus 2 limit R tends to infinity. What does that mean? लिमिट इंफिनिटी को अप्रोच कर रही है, आर की थीटा वेरी कर रहा है प्लस पाई बाय 2 से माइनस पाई बाय 2 की ओर. इस टर्म को देखते हैं. R is approaching to infinity. इस R के कंपैरिजन में ये 2 काफी छोटा है. इट मीन्स इस R के कंपैरिजन में हम इस 2 को नेगलेक्ट कर सकते हैं. R is a very big quantity as compared to 2, so we will neglect 2. These terms come out to be 1 by R square e की power j2 theta limit R tends to infinity. First of all, we will calculate its magnitude, then its phase. Magnitude of exponential. Magnitude of exponential is 1. So its magnitude will come out to be 0. अब बात करते हैं इसके फेज की. इस फेज will be e to the power minus j2 theta divided by r square. That comes out to be minus 2 theta. थीटा कहाँ से कहाँ जाएगा? प्लस पाई बाय 2 से माइनस पाई बाय 2. तो इस ट्रांसफर फंक्शन का फेज इस रेंज के लिए कहाँ से कहाँ जाएगा? माइनस पाई बाय 2 टू प्लस पाई बाय 2 टू दिस माइनस. That comes out to be minus pi 2 plus pi. मतलब C1 के लिए हमने ड्रॉ किया, C2 के लिए किया. Now we have to do calculation for C3 and then for C4. So I am going to erase this. लेकिन इसको erase करने से पहले इसका प्लॉट ड्रॉ करते हैं. This is my QS plane. At omega 0, magnitude is infinity, phase is minus 90. जैसे जैसे ओमेगा बढ़ रहा है, as omega is increasing, magnitude is decreasing, and phase is going from minus 90 to minus 180. So for C1, graph will be somewhat like this. Now for C2, magnitude is 0 and phase is changing from minus pi to plus pi. At this point, magnitude is 0 and phase changes from minus pi to plus pi. Now we will do calculation for C3 and then for C4. See, this was for omega equal to 0. This was for omega equal to omega approaching infinity. For C3, S approaches to minus j omega and omega changes from infinity to 0. What is this one? Z at minus j omega, H at minus j omega. 1 divided by minus j omega minus j omega plus 2. It's magnitude. 1 by omega into omega square plus 4. For phase, minus of tangent inverse omega by 0 minus of tangent inverse J minus नीचे के कारण this minus as this point comes out to be fourth quadrant. ओमेगा की डिफरेंट वैल्यूज के लिए कैलकुलेट करेंगे. ओमेगा and magnitude and phase. Omega goes from infinity to 0. Omega goes from infinity to 0. At infinity, 1 by infinity into infinity square plus 4. This term is very small as compared to this neglected 1 by infinity square. Magnitude will be 0. Phase of this is already 90 plus 90 at omega infinity. Tangent inverse infinity is minus 90, minus plus 90. That comes out to be plus 180. At omega 0, this is 1 by 0 into something 0. Is equal to infinity. Phase plus 90, 0, 0. It comes out to be plus 90. So we will go from here. At infinity magnitude is 0 plus 180. This point. Then जैसे जैसे ओमेगा घट रहा है from infinity to 0, magnitude is increasing and phase is changing from plus 180 to plus 90. As omega goes from infinity to 0. Omega goes from infinity to 0. Now for C4. Now for C4. That was limit r tends to 0, r e to the power j theta, where theta was going from minus pi by 2 to plus pi by 2. This आता. So that will come out to be 1 divided by r e raised to the power j theta divided by r e raised to the power j theta plus 2. Limit r tends to the 0. अब r 0 को अप्रोच कर रहा है. This term is very small as compared to this. So हम इसको नेग्लेक्ट करेंगे इसके कंपैरिजन में. That comes out to be 1 divided by r e की power j theta into 2. Now r is 0. 1 by 0. So its magnitude comes out to be infinity. Now अब बारी आती है फेज की. Now terms come of phase. इसका फेज कितना होगा? This is constant. फेज आएगा इसके कारण e की पावर minus j theta divided by 2r. So its phase will be minus theta. Theta is going from minus pi by 2 to plus pi by 2. It will minus from minus pi by 2 to plus pi by 2. So जो फेज निकल के आएगा that will be plus pi by 2 से to minus pi by 2. So for C4 magnitude is infinity and phase is changing from plus pi by 2 to minus pi by 2. Phase is changing from plus pi by 2 to minus pi by 2. This will be its Nyquist plot या Nyquist contour. अब तुम्हारे गेट के एग्जाम में तुम्हें इस टाइप का एक नाइक्विस्ट प्लॉट दिया होगा, इस टाइप का एक ट्रांसफर फंक्शन गिवन होगा, एंड यू हैव टू टेल whether the closed loop system made from this open loop system will be stable or not. तुम्हें बताना होगा कि इस ओपन लूप ट्रांसफर फंक्शन से जो हम क्लोज लूप ट्रांसफर फंक्शन निकालेंगे वो स्टेबल होगा कि नहीं, अगर ये नाइक्विस्ट कॉन्टूर गिवन है तो then you will use the equation n is equal to p minus z. Minus 1 comma 0 lies here. Does this Nyquist plot encircle this minus 1 comma 0? The answer is no, it does not. So value of n will be 0. P, number of poles in the right hand side in open loop transfer function. There is no pole in the right hand side of imaginary axis. So value of P comes out to be 0. So Z comes out to be 0. Means system is stable. Which system? Closed loop transfer function. The closed loop transfer function which we are going to make from this open loop transfer function is stable. चेक करते हैं, इस ट्रांसफर फंक्शन से मैं क्लोज लूप सिस्टम बनाता हूँ विद यूनिटी फीडबैक, दैट विल कम आउट टू बी 1 डिवाइडेड बाय s plus 2, 1 plus 1 divided by s into s plus 2, 1 divided by s into s plus 2 plus 1, 1 divided by s plus 2s plus 1. इसकी जो रूट्स आएंगे they will lie on the left hand side of the imaginary axis. So the system which is closed loop system is stable. जो चीज हमने नाइक्विस्ट प्लॉट से कैलकुलेट की थी वही चीज हमें लोकेशन ऑफ पोल से भी मिल गई. मींस हम नाइक्विस्ट प्लॉट का यूज कर सकते हैं किसी भी क्लोज लूप सिस्टम की स्टेबिलिटी बताने के लिए विदाउट फाइंडिंग इट्स ट्रांसफर फंक्शन. वी जस्ट वांट टू नो कि whether a closed loop system which is formed using this open loop system will be stable or not. Then we don't have any need to find out the transfer function of closed loop system. मुझे बताना है कि जो इस open loop transfer function से closed loop transfer function बनेगा वो stable होगा कि नहीं. Whether that transfer function, whether that system will be stable or not. तो हमें closed loop transfer function को निकालने की जरूरत नहीं है. हम इस इक्वेशन का यूज करके और नाइक्विस्ट प्लॉट को देख करके ही बता सकते हैं कि whether our system will be stable or not. तो कोई अनस्टेबल एग्जांपल लेते हैं. जो ओपन लूप ट्रांसफर फंक्शन हमारा अनस्टेबल हो, the same procedure you will follow to find out the Nyquist plot. Then you are going to calculate that whether the closed loop system is going to be stable or not. से मेरा ट्रांसफर फंक्शन गिवन है, मैंने इसमें थोड़ा सा चेंज किया. Here my open loop system is unstable. Without finding closed loop transfer function, I am going to see whether my closed loop system will be stable or not. मतलब मेरा open loop transfer function unstable है. Nyquist plot का use करके मैं find out करूँगा कि मेरा closed loop system बनेगा that will be stable or not. You will follow the same process. First you are going to calculate C1, C2, C3, C4, then the magnitude phase, and then you will draw its Nyquist plot. मैं सिर्फ तुम्हें समझा रहा हूँ कि स्टेबिलिटी कैसे फाइंड आउट करेंगे. सो इसका Nyquist प्लॉट जो बनेगा, that will be somewhat like this. This points comes out to be -1, 0. Here -1, 0 is encircled single line. Which direction? Clockwise direction. -1, 0 is encircled single line in direction, and is equal to P minus Z. N is -1. Clockwise minus number of poles in open loop transfer function in right hand side, 1 minus Z. Z comes out to be 2. So unstable. Now we are going to check the same thing using finding out the transfer function, so that we can confirm what we understand, that is right or not. मैं तुम्हें इसकी वेरिफिकेशन करवाऊंगा क्लोज लूप का ट्रांसफर फंक्शन निकाल के, ताकि तुम्हें पता लगे जो चीज़ हमने समझी है वो ठीक है कि नहीं. इसका क्लोज लूप ट्रांसफर फंक्शन क्या बनेगा? 1 डिवाइड बाय s minus 2 over 1 plus 1 divided by x into s minus 2. Here I am formulating closed loop transfer function. 1 s into s minus 2 plus 1. The poles of this root, of this transfer function, मतलब इसके जो roots आएंगे, they will lie in the right hand side of the transfer function as negative terms comes here. इसके जो roots आएंगे वो right hand side में होंगे. क्या roots होंगे? 1 divided by s minus 1, s minus 1. इसके रूट्स आएंगे, लोकेशन ऑफ पोल विल बी एट 1 and 1. मतलब इस ओपन लूप ट्रांसफर फंक्शन का यूज करके जो मैं क्लोज लूप बनाऊंगा, दैट क्लोज लूप विल आल्सो बी अनस्टेबल. वो क्लोज लूप ट्रांसफर फंक्शन भी अनस्टेबल होगा. ये चीज हमने यहाँ से भी कैलकुलेट करी थी. सेम थिंग वी आर गेटिंग here, value of z is 2. इसने बताया कितने नंबर ऑफ पोल्स होंगे राइट हैंड साइड में, दैट इज 2. दोनों पोल एक ही पॉइंट पे लाइन कर रहे हैं. sp is minus, sp is 1 and 1. So